2NURFM, a broadcast service of the University of Newcastle.
Professor John O'Connor, who normally walks in a very casual manner, he just came in rubbing his hands. You're freezing today as well. Good morning.
Yeah, I've got a very cold office. It's very hard to warm up, so yes, I've come outside to warm up.
He arrived about an hour ago, and I said, did you wet the bed this morning? He said, my office is freezing, so I thought I'd come down and take part of the warmth in your studio. Bask in it while we've got the opportunity. Now, we're talking about a space elevator, and if you're sitting there imagining this elevator where you walk in, you press a button and it plays Girl from Ipanema and you go up into space, it's not quite that. Can you explain the concept of what a space elevator does, why we need it and how it will work?
Well, it's interesting because it's a very old idea in the sense that it was first suggested in 1895 by a Russian. So that's even before they started firing rockets off. The idea is that, yes, we have this long cable which stretches well beyond the geostationary point, the point where satellites sit directly above one spot on the Earth. And what you have is this long cable, and on the end of it you attach, say, an asteroid or something, a couple of thousand tons of something.
Something heavy.
And you've got it under tension, but it will sit in the one spot as the Earth rotates. Now, this means, of course, the bottom end of this thing has got to be attached to somewhere near the equator. That's the constraint there. But the thing is, it then becomes a strand, and you can then build a climber, an elevator, something which would climb this thing, and It's quite some distance. I know it depends. If you want to go to geostationary orbit, that's 37,000 kilometres. Now, it's not the sort of thing you whip up in a few minutes. No. So it'd be a slow process. But there have been a number of very serious studies on what this would take and how much it would cost. And the costs are surprisingly little. In fact, it'd be less to build this thing than it would be to build a fast train in Australia.
Oh, please don't even go down that line of thought at the moment. And don't mention light rail, please, whatever you do.
No, I won't go there either. But anyway, so in terms of the costs, it's feasible, but the problem is really materials. You need something which is very strong and very lightweight, because you've got tens of thousands of kilometres of this stuff, and for a long time people were pontificating on the fact that some stage in the future we might have these materials. Now, a couple of years back they developed things called carbon nanotubes. Now, they're an interesting thing. They're made purely of carbon. It's a very strong material. It actually is a bit reminiscent. Do you remember those little Chinese puzzles you used to get in crackers at Christmas time? You put your finger at each end. They're made of bamboo, and you'd try to pull your finger out.
And they'd get stuck, and you'd have to go to the emergency room. Yeah, that was always a fun Christmas, absolutely.
So it is the same sort of structure. It's a spiral arrangement, but it's made purely of carbon. And these are an extension of what was called buckyballs, or the soccer balls made out of carbon, and they're very strong, very light. They have the same sort of bonds that diamond have. So there was a great deal of optimism that we could now build a space elevator out of carbon nanotubes. And there's been a lot of excitement. There's even been companies that have been formed to plan out a set of benchmarks, and they'd make this by certain times. But there's a bit of a fly in the ointment, because a group in Japan have just recently discovered that you need to have these things perfect along the whole length. If you have an atom out of place, or if you have just one bond a bit wrong, it seriously weakens the tube. So one atom somewhere along that line basically halves the strength. Now, as it was, the strength was just at the borderline to make a space elevator.
Feasible, yeah.
But if you just have one fault, the thing is that breaks and then shares the tension on the surrounding atoms, which then start to give as well. So you only need this one fault to halve the strength. So,
and it's a domino effect of breaking, basically.
That's right, and just sort of unravels, rips open.
What are we going to take up the space elevator?
Well, the thing is, it's so much cheaper than sending up rockets. I mean, if you at present it costs something like $25,000 per kilogram that you send into space, and that's cheaper than it used to be. But if you did it by space elevators, we're talking hundreds of dollars rather than tens of thousands of dollars. So it'd be very cheap to get things not only into Earth orbit, near Earth orbit, but if you had this long enough, and the asteroid sitting on the end of this tether would actually be beyond geostationary orbit, you could actually just take things up to that point, release them from there, and they'd escape Earth orbit. So it's a really cheap way of getting things either into orbit, like our communication satellites and so on, or getting things out to explore the rest of the solar system and beyond.
Can I ask one silly question before you leave this morning, go out into the cold? Have we got an asteroid kicking around that we can use at the moment?
Oh, there's plenty sitting around. Actually, I was tempted to talk.
I thought you'd say no, but I didn't realise there were plenty sitting around.
No, in fact, I was tempted to come up with a different story this morning, although it's a harder one to explain. There's an asteroid that's playing leapfrog with the Earth at present. As the Earth orbits the Sun, this is not orbiting the Earth, it's actually orbiting the Sun, but in such a way that it actually, from time to time, gets closer and further away from the Earth. So it's not a simple orbit like the Earth. It looks like a spirograph.
Yep.
But yeah, there's one sitting out there that's tailing along like a faithful dog. And there are a few others out there that we can capture. I mean, in fact, asteroid mining is the next big thing in space discovery. Is actually going out, lassoing an asteroid, bringing it back to near Earth orbit, because some of the metal. The metal asteroids that you can find, they're almost pure metal, cobalt, iron, etc., and probably enough platinum in there to swamp the world market.
There's never a dull day in your life, is there? I didn't think so. Professor John O'Connor, and that's another story for another day. Stay as long as you want. I'm heading out at midday, so if you want to stick around and stay warm, you're most welcome to.
Thanks, Tom.
Professor of Physics at the University of Newcastle.